Am I audible, students? Hope I'm audible. I'll share the content. I will do the quick revision of this thin cylinder. Okay. So the main was the derivation of hoop stress and longitudinal stress. Apart from that, I'll share the PDF and all. I already shared the notes also for different change in dimension, change in volume. What will be the formula? Derivation is not required. Just remember the formula. Okay. We'll do the quick revision of this thin cylinder part. And from the next class, we'll see your thick cylinders. Screen is visible? Sorry. Screen is visible? Okay. Thank you. Thank you for the responses. Okay, proceed. So when the thickness of the wall of the cylinder is less than 1/10 to 1/15 of the diameter of the cylinder, then the cylinder is considered to be thin cylinder. Okay, the thickness, this thickness, this is the T value. This T value represents its thickness, and this is the diameter. So when your thickness of the cylinder is less than 1/10th to 1/15th of the diameter. So if your diameter is 20, 1/10th of this diameter, or you can say 1/15th of this diameter. So this T value should be less than, it's 20 1/10th or 2 or 1/15 times of the diameter of the cylinder. Okay. So if your thickness is that much less than this value, so your cylinder will consider as thin cylinder. Okay. Basically thin means your thin thickness. Okay. Thickness will be less. Otherwise, if the thickness is more than the diameter of the cylinder, then it will be considered as thick cylinders. Okay. So if you take a rectangular sheet of some thickness, where L is the length of the cylinder, D is the diameter of the cylinder, T is the thickness of the cylinder, and P will be internal pressure due to fluid. Okay. If if you roll it out, you will get a cylindrical shape or circle shape. Okay. So generally, these are the examples where your thin cylinders are used. LPG cylinders, boilers, storage tanks, all are thin cylinder. The thickness of these cylinders are very small compared to their diameter. Okay. Now, due to the fluid inside, say in LPG there is some nitrogen, right? Boilers, storage tank. Usually, where we see the storage tanks, mainly in refineries. What they do, what is the purpose of this storage tank? They store liquid or sometimes gas. So, due to those fluid and gas, these are subjected to fluid pressure, or you can say internal pressure. Just take an example of your Coca-Cola can or Pepsi can. In that can you will have fluid, right? So that fluid will exert pressure on the walls of the can. Okay, just imagine you have a can of that Coca-Cola can bottle, and it is completely full. When you release the that what it is say, you release the cap, there is some gas released, right? That the pressure of that liquid, it is applying on the walls of the cylinder. Okay, so due to these fluids inside a cylinder, these are subjected to fluid pressure or internal pressure, which is represented by here P. Okay, or you can give any name, but they have represented here it with P. Okay, so hence at any point on the wall of the cylinder, three types of stresses are developed. So mainly three types of stresses will generate: hoop stress, longitudinal stress, and radial stress. And in case of thin cylinder, this radial stresses are negligible. Okay, so we'll normally consider these two stresses only. One is circumferential stress or hoop stress, another is longitudinal stress. So let's see with the assumptions. What are the assumptions in thin cylinders? Number one is it is assumed that the stresses are uniformly distributed throughout the thickness of the wall. So remember this line is very important. We'll do some MCQ in the second part of the class. First, see, the stresses are uniformly distributed throughout the thickness of wall. So, suppose this is your cylinder. So, this is your cylinder. So, the pressure in from the liquid inside this cylinder will be uniform. Suppose here, if here it is acting 5 kilonewton, here it will act as 5 kilonewton. So the stress distribution, or you can say the stresses are uniformly distributed throughout the thickness of the wall. But in thick cylinder, the stresses are not uniformly distributed. Okay, that we'll discuss in next classes about the thick cylinders. But the first assumption of thin cylinder is that your stress is uniformly distributed throughout the thickness of the wall. Okay. Next, as the magnitude of as the magnitude of radial stress is very small in thin cylinders, they are neglected while analyzing thin cylinders. So I've discussed this one. The radial stress in thin cylinders are very less. Okay, it will have in very less value. So that's why we neglect this stress, and we are just only interested in finding out the hoop stress and longitudinal stress. Okay. In general, in cylinders where you have liquids, you will experience these three stresses. But in thin cylinder, the radial stresses are very less. That's why we consider only these two stresses. Okay, this is one more important point. So let's discuss the stresses in detailed manner. So circumferential stress, or you can say hoop stress, this stress is directed along the tangent to the circumference of the cylinder. So as the name says circumferential, so it will act along the surface. Okay, it will act along this surface. It is tensile in nature. It will see these arrows. Let me draw. See these arrows. These arrows. Okay, this will try to apply as much pressure. It is also called as bursting pressure. It will, if this increases compared to the resistance of this cylinder, then your cylinder will burst out. Okay, why it is said bursting pressure? Because it has a tendency to burst this cylinder. Okay, and these stresses tends to increase the diameter. So when it will apply force in this direction, so definitely it is increasing the diameter. Okay, the bursting in the cylinder will take place if the force due to internal fluid pressure actually acting vertically upwards and downwards become more than the resisting force due to circumferential stresses developed in the cylinder. Due to its thickness and due to if this circumferential stresses will not be able to resist this internal pressure, then it will fail or it will burst out. Okay. So here is the derivation. We have seen the derivation, so I will not go with the derivation. So the circumferential stress has formula of PD by 2T. Okay. Next, longitudinal stress. This stress, it is also represented by sigma L. This stress is directed along the length of the cylinder. So hoop stress acts along the circumference. Longitudinal stress acts along the tangent along the length. Okay, this is also tensile in nature, and this stress tends to increase the length. So hoop stress tries to increase the diameter, and this longitudinal stress, it tries to increase the length. Okay. Again, these are the derivations we have discussed already, and this is the formula PD by 4T. Okay. Now see, due to the presence of longitudinal stress and hoop stress, there will be some shear stress. Okay. Due to the presence of longitudinal stress and hoop stress, there is shear stress developed in the cylinder, and this shear stress maximum in plane shear stress is given by. So the maximum shear is given by PD by 8T. So remember this point. Your hoop stress is PD by 2T, longitudinal stress is PD by 4T, and your shear stress is PD by 8T. Okay, now here comes the important points. You should remember these formulas also. Okay, when you have stress, when you have longitudinal stress, so definitely there will be a strain. Okay, it due to this hoop stress or longitudinal stress, there will be some strain. And what is strain? Comment down in the type in the chat box. What is strain? What do you mean by? What do you understand by the term strain? Text me privately. What do you mean by strain? What do you mean by strain? Okay. What about others? Good. Atul, good. Ivan, good. What about others? 32 students are there, only 2 replied. What about others? Others are sleeping? Hmm? I won't give attendance till I get reply. What is strain? Now I am in 5th semester. What is strain? Good. Jamir. What about others? Orup, Atul, Christina, huh? Kennedy, Richa, just joined or no? Good. So let's continue. So due to this longitudinal stress, there will be some strain. Okay, there will be some change in dimension, right? So this is the formula for longitudinal strain. This is the formula for circumferential strain. Okay. See, the formula is almost same. There is some difference in T value and 1 minus 2. So just follow up this. Okay. You'll get easy numericals based on this formula only. So please go through this. Just give me a minute. Go through this formula one. Okay, so this is the longitudinal strain formula, this is the circumferential strain formula, and this is volumetric. Okay, just go remember these formulas. Derivation is not required. Now see, this is very important point from numerical point of view. Okay, suppose in the question you have been asked to find out the major principal stress in a cylinder. So what they are asking you to find out they are asking you to find out the hoop stress or circumferential stress. So your hoop stress and circumferential stress will be the major principal stress on the cylinder. Okay, and your minor this longitudinal stress will be your minor principal stress. So keep remember this. If don't get confused, they might ask you indirectly that find out the major principal stress. So what you have to do, you have to find out the sigma h. And if they ask you to find out the minor principal stress, then you have to find out the longitudinal stress. Okay. Now see, if sigma t is the permissible stress for the cylinder material, then major principal stress should be less than or equal to sigma t. So sometimes they might ask you what should be the thickness of the cylinder so that your cylinder doesn't get failed. Okay, so what you have to do, they will give you some permissible stress. Permissible stress means till this much stress we can allow in a cylinder. Okay, we can allow the stress will not fail up to this stress. So that is called permissible stress. So this line says that your hoop stress sigma h, your hoop stress should always be less than or equal to the permissible stress. So if you place the formula in this way, then you will find out this one. Okay, this means that your thickness, the thickness should be always be more than and equal to PD by twice sigma t. Okay, if your thickness is less than this value, then your cylinder will fail. So always when this question will come in the designing part, when they will ask you a designer or tell me the just tell me the thickness up to which your cylinder won't fail, and they will give you the permissible stress on also. So you have to use this formula to find out the thickness also. Okay, understood? Okay. So next is your, in order to produce pure shear state of stress in thin cylinders, you have to use these conditions. So these are the few conditions. Okay. Maximum shear stress in wall of cylinder is given by this. Maximum shear stress is given by PD by 40. Okay. Now see, this is the point from the first class. In case of thin cylinders, in case of thin spherical shell, longitudinal stress and circumferential stress are equal and given by this. Last class we discussed only in spherical shape what will happen, your longitudinal stress will equal to your hoop stress, okay, and it will be PD by 40, okay, and it will be in tensile in nature, and the shear stress will be 0. Okay, understood? Well, this is from the last class only, the first class only. So you have to remember these 5 points while analyzing or solving some problems based on thin cylinders. Any confusion? Hmm? Any confusions? Okay. So I'll ask some questions. You have to reply me privately. Okay, I'll ask some questions. You have to type your answers in the chat box privately. So hear me correctly. Okay. Get ready. I'll ask some questions. If the thickness of plate, am I audible? Okay, I'll write the question. You give me the answer. Okay. If the thickness of plate is negligible, if the thickness of plate is negligible, when compared to the diameter, if the thickness of plate is negligible when compared to the diameter of the cylinder, then it is called. Send me the answer privately. If the thickness of plate is negligible when compared to the diameter of the cylinder, then it is called. Send me the answers quickly. Good, Atul. What about others? Reply. I'll take surprise test one day. In next week. Next week I'll take the surprise test, okay? Good. Only four of you replied. What about others? Others don't want an attendance, I guess, right? I won't give attendance if you don't reply. The thickness should be dash times of internal diameter. Okay. Atul, Christina, 81, 70, 54, 71, 93, 91, 76. Only these people replied. 1, 2, 3, 4, 5, 6, 9. 9 students, 10 students. Just now we discussed this topic and why you're not able to answer me? Okay, I'm putting the second questions, okay? If in thin cylinders, time up. Time up for the first question. Next question. In thin cylinders, the thickness should be dash times of internal diameter. How much it will be? Time up for the question number 1. Reply for question number 2. In thin cylinders, the thickness should be dash times of internal diameter. Answer this one. Answer me the second question. See, good. So see, somewhere you will get between, it will be 1 by 10 to 1 by 15, or you can take 1 by 20 till 1 by 20. Okay, the answer will be 1 by 20. Okay, so don't get confused. Somewhere will be given 1 by 10 to 1 by 15. That also correct, but approximately maximum in cases they take 1 by 20. So answer will be 1 by 20. Okay, I'm putting the next question. Please answer for this. Oil tanks, steam boilers, gas pipes are examples of oil tanks, steam boilers, gas pipes are examples of good Atul, you're replying very fast. Good. Be active in the class. Good. All tanks, steam boilers, gas pipes are examples of. Good. Okay. Anyone want to answer? Good, good. Atul, then 54, 71, 76. Takar Kino 72, 87, 84, 52, 120, 93. Christina 82, 78. Good, very good. So I'm putting the next question. Answer me this one, okay? In dash cells, the stress distribution is not uniform over the thickness of the material. See, these are the very easy basic questions I have asked. I For the section A, I discussed first this question, then I showed them the PDF file. But in your class, I have shared the PDF first, then I'm discussing this uh, easy MCQs. So you should answer now. Suraj good, Atul good. In dash cells, just now I have discussed this point. The stress distribution is not uniform over the thickness of the material. Jamir, you are wrong. KKJT91, you are wrong. Yes, only few students. 81, you are wrong. That's when you are not. 54, you are wrong. Oh, no. Okay. 81, you are wrong. Please go through this video or go through your materials, then you'll understand. And today also I have discussed this point. Okay, let me discuss the answers also, okay, from the first. So for the first question, if the thickness of plate is, so for this one, this answer will be thick cylinders, okay. Stress is uniform in thin cylinders, okay, and it is not uniform in thick cylinders. Likha, you have raised hand, anything? Any issues? Okay, let me discuss the question, let me discuss the answers first. So the first question was, if the thickness of plate is negligible when compared to the diameter of the cylinder, then it is called thin cylinders only. Okay, right? The thickness is less than the diameter of the cylinder, so it will be thin. And if the thickness is more compared to the diameter of cylinder, it will be thick. Right. Next, in thin cylinders, the thickness should be 1 by 20 times of internal diameter. Okay. And the next question it will be, oil tanks, steam boilers, gas pipes are the examples of thin cylinders. Okay. Then in dash cells, the stress distribution is not uniform over the thickness of the material. So it will be thick. Okay. Now just tell me the last question. It will be shear stress and okay, so what will be the shear stress in spherical thin cylinder? This is the last question of the class. What will be the shear stress in thin spherical cylinder, or you can say spherical thin cylinder? Yes, response. What will be the shear stress in spherical thin cylinder? What will be the answer? Not able to find out in Google? Hmm? What will be the shear stress in spherical cylinder? Or you can take what will be the shear stress in spherical shape thin cylinders. I've discussed this line twice. So whatever you know, just type in the chat box. Good. What about others? Good. Roll number 50. No, I'm asking you the value. What will be the shear stress and at least you guys replied. Good. Roll number 76, 63, 93, 54. Very good. Good, Ivan. Very good. Alison Jamil. No. Good. You replied. What happened to others? Norup, Christina, Madhusmita, Ruposhri, Hisol, Kennedy. What happened? You are not replying any of this. Okay, so the answer will be 0. Okay, we know the shear stress is PD by 80, but when the structure is in spherical shape, what I said, when the structure is in spherical shape, your longitudinal and hoop stress, or you can say circumferential stress, will be same, PD by 40, but the shear stress will be 0. Okay, go through the notes. Okay, once more. Go through the notes, go through this video, then it will be more clear, I guess, because I have discussed the same thing again and again. Okay. Anyways, so let's end today's class here. All of you write your roll numbers in the chat box, please. Don't leave the class, just write your roll numbers. Okay. Anyone left to write their roll number? Last one is the 74. Anyone left? 72. 68. Anyone left? Okay. I hope everyone wrote. Okay. 85. Anyone left, please write your roll number fast. Okay, hope everyone wrote their roll number. So see you in the next class. Okay, thank you.